section on Delta sharing. We're going to tackle one of the most important aspects of modern data governance, which is how to securely share data with external partners without compromising control. In our Zava automotive scenario, we need to share vehicle telemetry data with manufacturing partners who help us build electric vehicles, and we need to share sales analytics with external consulting firms who don't use Databricks. The challenge is doing this securely while maintaining full visibility and control. Delta sharing in Azure Databricks lets you share live data without copying it. Think about that for a moment. Your partners can query your tables directly, but you never lose control. You can revoke access instantly. You can see exactly who accessed what and when. And you never have to worry about copies of your data sitting in systems you don't control. The first decision you need to make is which sharing protocol to use. Delta sharing offers two primary protocols, and your choice affects how authentication works and what you can share. Databricks to Databricks sharing is the preferred option when your recipients have access to a Unity Catalog-enabled Azure Databricks workspace. This is fantastic because all the security is handled automatically by the platform. Your recipient provides their sharing identifier, which is a unique string containing their Metastore's cloud region and ID, and the connection establishes without any token management. You can share tables, views, volumes, notebook files, and even AI models through this approach. It's seamless and secure. Open sharing is what you use when recipients are on platforms other than Databricks, or they don't have Unity Catalog. Maybe they're using Tableau or Power BI or a custom Python application. With open sharing, you manage authentication by generating bearer tokens or configuring OIDC federation, which is OpenID Connect. This approach is more flexible, but it requires careful token lifecycle management. And you can only share tabular data, not volumes and models. Let me give you concrete automotive examples. For our manufacturing partner, who also uses Azure Databricks, we'll use Databricks to Databricks sharing to give them access to vehicle telemetry data from our electric vehicle fleet. They need that sensor data to improve battery performance and motor efficiency. Since they're on Databricks with Unity Catalog, this is straightforward and secure. For our external analytics consulting firm that uses Tableau for their visualizations, we'll use open sharing to provide vehicle sales summaries. They need to build dashboards for our executive team, but they don't have Databricks access. We'll generate a bearer token for them, and they'll connect through the Delta Sharing Open protocol. Here's a quick comparison to help you decide. For a recipient platform, Databricks to Databricks requires Databricks with Unity Catalog, while open sharing works with any platform. For authentication, Databricks to Databricks is platform managed, while open sharing requires tokens or OIDC. For shareable assets, Databricks to Databricks supports tables, views, volumes, notebook files, and models, while open sharing only supports tables. For token management, Databricks to Databricks doesn't require it, while open sharing does. And for performance, Databricks to Databricks is optimized with history sharing capabilities, while open sharing provides standard performance. One important thing to note is that you're not limited to one protocol per organization. If you have a partner who has some users on Databricks and some on other tools, you can create multiple recipient objects for the same logical organization, one for each access pattern. Now that we've chosen our protocols, let's talk about how to secure them properly. A secure sharing strategy starts with proper authentication configuration and follows the principle of least privilege. For open sharing recipients, you should configure token expiration to limit exposure if credentials are compromised. Set the default token lifetime at the Metastore level rather than leaving tokens active indefinitely. Navigate to the account console, select your Metastore, enable Allow Delta sharing with parties outside your organization, and set an expiration period. This ensures that even if a token is leaked, it won't be valid forever. For recipients who shouldn't have to rotate tokens frequently, like long-term strategic partners, consider OIDC federation instead. This approach grants short-lived Databricks OAuth tokens in exchange for JOT tokens from the recipient's identity provider. This removes long-lived credentials entirely from the equation. The recipient authenticates with their own identity system and gets temporary access tokens that expire quickly. You can also restrict network access for sensitive shares by assigning IP access lists to open sharing recipients. This limits access to specific IP addresses or CIDR ranges. For example, we might restrict access to our manufacturing partner's office IP addresses so that even if someone steals their token, they can't use it from a random coffee shop. Each recipient supports up to 100 IP or CIDR values. When a request originates from an unlisted address, Delta sharing denies access and logs the attempt. Now let's talk about privilege delegation. Rather than granting Metastore admin access broadly, use specific privileges. Create share allows creating new shares. Create recipient allows creating new recipients. Use share and set share permission together allow granting share access to recipients. And use recipient allows viewing recipient details. Assign these privileges to groups representing your data stewardship team rather than individuals. This follows the principle of least privilege and makes it easier to manage access when people change roles. After designing your security approach, let's actually create the share and objects in Unity Catalog. This is where theory meets practice. For this demonstration, we have two workspaces,